Another draft science presentation. Anyway, so it's mostly gravity, I think, and the general subject of what is a convincing argument, I suppose, or what is solid evidence. And so this is just sort of a recurring theme of this conversation, is that if you're disputing the integrity of the current model and you're replacing it with a model that just say the evidence is more persuasive. And I suppose I'd argue that even if they were equally persuasive, or even if your model, the existing model, could in some way through evidence be proven or demonstrated to be a much better model, it's more consistent, the evidence is more consistent with one than the other, then you should be able to argue that without all this personal stuff where the people's only argument seems to be is that you're not allowed to dispute the authorized, the eggheads know what they're doing, and even if you demonstrate repeatedly how a lot of the assumptions and presumptions, the established jargon, has been inaccurate. I mean, the single double slit experiment is a prime example, a very simple experiment, very rarely described by conventional physics accurately, used as a show experiment, and and the facts be damned, so to speak. You can kind of demonstrate that they really just don't care about the truth. And I've shown with the interferometer that there's a whole lot of questions about what exactly beam splitters are doing, and the whole theory of quantum mechanics, this idea that somehow it's photons interfering with each other when they're trying to get somewhere, that it sort of breaks down when you start analyzing how the energy moves through the experiment, and you realize that you can create these very sophisticated patterns without any real opportunity for anything called photon interference. So, but all that is ignored in terms of a preface for the argument that then when they make these really elaborate claims, like they say things like there's an antiparticle, and Feynman speculates that it moves, that the antiparticle is really the electron and its positron, or one's just moving backwards in time. Explanations that are just made up. I mean, there's no evidence that anything's moving back in time. It's just some excuse, some way of saying or rationalizing its behavior, and saying that if you make this thing go backwards, it'll look like that other thing. The opposite. If I turn my left hand right, if I turn inside out, it'll look like a right hand. Does that mean it's the anti-right hand? No. So, and then they have whole theories about this, once you start things going backward in time, then every electron is the same electron in the entire universe, and they go, just lots of just imagination gone wild. And they think this is good science, when there's no evidence for any of it. It's just made up. And so I sort of argued that bent space, there's no evidence that bent space is the explanation for the inverse square law, and that's all that bent space is saying. It's just a description of the inverse square law. So the images over here are my attempt to illustrate that that's all that we have. Einstein's bent space, there's no catch to it. There's no piece of evidence that it and only it explains, kind of a thing. That just doesn't exist. And so the whole idea of bending space-time, the evidence isn't that time is bent. The evidence is that velocity affects the function of material objects, that they change when they're moving. They're physically changed. And so clocks don't work the same because they're physically changed. And the other element is the gravitational element. And all it's doing is describing the inverse square law. That is how the force, if you consider it a force, how it spreads or how it affects things at a distance. So I've drawn like the bullseye kind of thing. That's the gravitational well. So you can draw it and say, okay, where the lines are thicker, the force is weaker. Where the lines are closer together, it's stronger. And so the other drawing with the little spikes sticking out is a way of illustrating that. Close to the object, the lines are close to each other. Far from the object, the lines are farther away. That means less force. And that's all the inverse square law is saying. That's basically a diagram of it. And you can understand it as being exactly the same effect as stuff coming in. So you can just look at those lines and you can say, well, what does that represent? And it just represents, you could think of it as lines radiating out, or you can think of it as lines radiating in. And that as you get closer to the object, the little bits will finally all hit you, so to speak, in close proximity, in greater density. And every object would feel that in a field of pressure, in a field of light, for example. If you're exposed to a whole bunch of lights, they'll behave the inverse square law. And the closer you get to the lights, the more photons will hit you. And that's the inverse square law. It's not a complex thing in any way. It's really simple geometry. And there is no evidence that the explanation for it is bending space. You don't need to bend space to explain it. You can explain it with lots of explanations that don't have anything to do with bending some kind of thing that we are traditionally thought of as being nothing. So you still have to call it some kind of thing like bent ether or something. And so one of the counter facts, the facts that make it doesn't sound too right, is the fact that we know this bent space moves at the very same speed, okay, that we know photons move at. Same speed. And we kind of know that photons aren't bent space. We know that they're little discrete things that tend to move in rays and straight lines. So very much like that diagram, we know photons move in straight lines like rays, and that we know they'll hit you, more of them, the closer you get to their source. And frankly, if you're in a field of them, you're going to get hit by a certain number of them, no matter where you go. Every spot in space will have that number. I mean, I can move parallel to the light, and I'll be hit by just as much light to my left as I will to my right. And gravity works the same way. It spreads out. And so you don't need to bend space. It's one explanation. It's one egghead explanation. And there's lots of other explanations that fit the evidence, and I would argue they fit it better. And I would argue that a particle explanation, or at least one that relies on corpuscles of energy that travel in rays or in straight lines, fits the evidence better, because it explains both photons and gravity then. And clearly magnetism does the same thing. The virtual photons talked about by Feynman are ray photons. They spread out like light and affect the other body. It's a force, a real force. Now you could try to bend it. You could say it's bent space, moving in little discrete bits. But does that really work? To particularize bent space? To particularize some contraction in distance and say the contraction travels, again, the speed of light? So when these people preach that this is unassailable theory, that somehow no one has a right even to question these people unless they can prove they have the higher IQ or something. I mean, does it really require that? I mean, really have to do that? Or you have to be a doctorate in the conventional babble. So you either go to their Pope school and preach their religion, or you're not qualified to have an opinion, which is obnoxious, really obnoxious. And I suppose, I mean, you could argue that might be a way of obtaining credibility, is to go to college when you're 50 years old, and to get your degree in their nonsense just so you can be qualified to dispute their nonsense. you know, but it's not very practical. And obviously, most of the people who get their degrees when they're young, and probably before they had time to develop any kind of theory opposed to the conventional theory. It would have been interesting if I had, you know, I was accepted at college and I was going to be taking physics, and I'm not sure I would have. I was taking physics courses because I was going to take general engineering courses, but it seems likely that I would have gravitated towards physics. But I had already held opinions about physics, like, for example, the nature of photons. I never accepted that it's true that photons are this wavy thing, electromagnetic wave thing. I saw no reason. The evidence doesn't demonstrate them to be waving in any way, and the only evidence that does, again, are these little particular experiments, small number of experiments in the total of experiments with light, a tiny percentage of the experiments with light that somehow demonstrate a curiosity that can't be explained, and therefore I guess create enough doubt in some people's mind to say, well, we'll just blow up the whole idea of this straight line particle that Feynman described as goes to from point A to point B in a straight line unless it hits something. You know, we'll just ignore that and pretend it's something a lot more complicated and doing a lot more complicated things. So anyway, the point is, it would have been interesting because I definitely would have gone into an education, a further education in physics, with some skepticism, because I didn't see the evidence. I didn't see any huge necessity to blow up the entire, all of the reasoned evidence that light travels in rays and that those rays aren't doing any of this crap. You know, they're not doing any of that crap. They're just little bits at a frequency. So anyway, so the other diagram is basically a cheap version of gravity, in the sense that to understand it, you sort of just have to understand the idea of creating shadows and the angles at which things will interact with each other in free space, when that free space has a bunch of force in it, a bunch of pressure, and both objects can shield each other from elements of that pressure by absorbing it. You know, by simply moving, they absorb the pressure. They take something that's moving the speed of light, the force, the bent space, whatever you want to call it. You know, the bent space is moving the speed of light. They absorb something moving the speed of light, and they move much, much slower. So the planet Earth moves. It's absorbing force moving the speed of light, but it's moving a lot slower, so it's holding that force inside of it, essentially, to move. It's spreading that force over its entire mass to move all of its mass. And so it absorbs a lot of force going the speed of light to go very slow, but it's very heavy. You see. And when it does that, the field around the other object, the sun, for example, changes. And now there's more force pushing it in one direction than pushing it in the other direction. And it is because it tends to absorb a percentage of the force it's hit with. It absorbs more going this way than it absorbs going this way, so it moves. And it does the same thing. It spreads a bunch of speed of the light force, spreads it over its entire mass, and moves the mass much slower. But the sun, percentage of the sun, 1/1,000,000th of the sun, let's say, or 1/500,000th of the sun's total mass, moves. You know, the sun's much bigger than the Earth. You know, it's not much more massive, so it's probably a number like more like 1/10,000th of the sun's mass moves this far. You know, this slowly. So its center of gravity changes a little bit, and that basically explains Mercury's precession problem, where Newton didn't get it right. And that's the difference, is Newton didn't recognize that the sun is processing it, that its center of gravity is wobbling in space, and that wobble affects Mercury's wobble, and it affects all the other planets, but much smaller because they're so far away that the little tiny wobble, little tiny wobble from far away doesn't mean anything. But when you're close, it means a lot. So Mercury is more affected than the other planets. The same error, Newton's math had the same error for all the planets. It's just the error is so infinitesimally small on the other ones because they're so far away. And the only one it really mattered on was Mercury because it was close. So here you have a whole theory that people are all glued to, like this has to be the truth, is spent space, warp time, blah blah blah. And it's not based on any real hard evidence. It's just based on the fact that there's an inverse square law, and that this is the way the force is what's the right word? How it reveals itself. How it it's a better word for that. How it's exercised, there's lots of other rational ways, perfectly reasonable ways to explain the phenomenon without having to resort to imaginary, ethery, spacey, bend things that we can't see or understand, when we have plenty of real-world examples of the thing functioning, like photons, like the cosmic background radiation. We have evidence that there's lots of these little bits in the universe already, and all your imagination is required to do is to say, yeah, there's a few more that we don't see because they don't have a frequency, and we can't measure them by measuring their effect on electrons. So they do this, they're definitely affecting things, they're moving them, but we can't see them, and we can't see magnetism, because magnetism is exactly the same force. It's just the force in magnetism. See, gravity is made out of this, black and red, two little different kinds of force. That's why it's drawn that way in some of the pictures there, and they're all mixed up in the field. And what a magnet's just doing is segregating them. All the red go out one way and all the black go out another way, and they affect each other differently, as I've explained. But it's the same force. So to see magnetism, to see little magnetism force, or the virtual photons they say are magnetism, to see them would be the same as seeing gravity, because they're made out of gravity. They're the same thing as gravity. They're gravity filtered, and that's it. Simple explanation. Perfectly works, explains the evidence, and it explains it with things we already have in the universe. And so photons are just these, the black stuff. Okay, the red stuff is the proton stuff. It isn't doing the photon thing at a frequency thing. There's no way to detect it. So even if you made the red stuff at a frequency, you wouldn't be able to detect it because it doesn't pop electrons out of their orbit. But the black stuff will. The black stuff is the stuff that repels electrons. It reflects off of them. So it can pop an electron, it can move electrons, and that's the important bit. It'll move them more. And all a photon is this stuff at a frequency. It's just gravity with a frequency. So it's a piece of segregated gravity at a frequency. One kind of the two kinds of gravity at a frequency. And there's your explanation for the entire electromagnetic spectrum. And none of it has to be doing any of this stuff anymore. None of it has to be doing any of this complex, weird, wavy stuff in fields of some kind, in ethers. I mean, they should just call... See, I always thought that's another thing where, when I went to school, it was perfectly legitimate to think of fields as being basically force fields. The field is essentially is a description of what the force is doing. I didn't have any notion that fields were some sort of thing that just sat out there, and somehow you perturbated it. Somehow you activated the field. The field was always there, and like the corn was always planted, and you didn't have to plant it. You didn't have to make the corn with a force. It was always there, and all you're doing is waving somehow the field. It was never my notion of how the game worked, because I guess I kind of already knew that photons were sort of a force without actually saying it. my brain sort of intuitively had already put that together as a reasonable statement that this stuff moving was like the little asteroids. It was already a force. It was already like a sandblaster. It was already little bits being flown at something, and it's going to affect it. And that would be the field. It would be a field of sand from the sandblaster. But it wasn't like there was already sand in the universe, and the sandblaster just told the little bits to move somehow. So forces were always the cause of a field of force. So, and forces were always something, not nothing. But like I said, I hadn't put it all together enough to be able to say that I understood entirely that I visualized gravity or magnetism as being made of the same thing as a photon, which would have resolved it so simply. But I didn't go that far then. So all I had was this idea that I knew there was something going between the two things. I knew there was something communicating between them, and it wasn't something everywhere. That magnetism wasn't everywhere. There wasn't some sort of magnetic fieldy thing everywhere. There clearly was only magnetism where there were magnets involved. Somehow you had to be a magnet to be relevant. You had to be a filter, and that the force, like now that I know, it was just gravity all the time. It was just this simple gravity stuff just going through a filter, and it comes out at the other side different than how it went in. Goes in all mixed up, comes out all filtered. Very simple answer. No need for all this egghead, fence space. No need to create all kinds of new physical instruments, and that's all physics does now. So I would argue that the antiparticles are an invention. Very little evidence, just a tiny shred of evidence, because we can't see electrons. We can't see them directly. We can only see them indirectly. We can only see protons indirectly. We only see any of this stuff indirectly. You can't see it directly. You can't watch it move through something. You have to watch it hit things and cause photons to be released. They have to have a very elaborate interaction, a very substantial interaction for us to know it was there. Little interactions we're not going to have any way of detecting. But anyway, so the point is, we don't see anything traveling anywhere. We certainly don't see it traveling at its normal speed or any of that. And all these conclusions drawn in this fog, and these people, that's the amazing part, they won't even admit that something like a cloud chamber or a bubble chamber, which looks exactly like fog, so it should be a clear association. They should be able to put those words together and say, yes, we're watching things move through fog. And they should think that, oh, that's kind of a foggy way of looking at the universe and deciding the truth. That maybe that's not what you call really strong evidence when you're looking through fog. That's not a way to see things exactly as they are. That's a way to see things distorted and perverted rather than as they are. And they didn't even put those, they didn't even add that 2 plus 2 in an honest way. And so you have conversations here, and these people are just so obnoxious, and they just claim you can't dispute these brilliant theories that completely answer everything, that don't answer everything, that in my opinion create more mess than value. I mean, antiparticles, annihilation events that aren't annihilations, clearly, dark matter, dark energy, vacuum energy. I mean, all kinds of just, made up fluffy theories that have so little hard evidence to defend them. And then even get on the subject of time dilation, or you get on the subject of gravitational lensing. These evidence, this hard proof. No, there's a little bit of evidence that there's a huge correlation between motion, velocity, and time dilation. And motion can be hidden. So as I've argued, as we sit here on Earth, maybe I should draw this part. Yeah, let's do that. This should work, maybe. Yeah. So if we sit here on the planet, it seems like we're just standing still here. We're stuck. We can't go anywhere. The force comes down. I guess I should draw the force in red just for fun. So the force I'm arguing is this disproportional force. More arrows come down, and the Earth blocks the arrows coming up. So it's like there's only 3 arrows hit you from the bottom, and 4 arrows hit you from the top, and that's your gravity at different locations. You'll have a different number. But it's because this Earth absorbed the energy. So technically, as you're falling down, little bits of the Earth are going up. So if you weigh 150 pounds, as you're falling, there's 150 pounds of the Earth, all right, that's actually rising. But it's 150 pounds and a gigantic thing, so you don't see it, but it actually is happening. For you to gain velocity, the Earth had to essentially stop force from getting to you, and it stopped it by absorbing it. So it's moving, little pieces of the Earth are moving as fast towards you as you are moving towards the Earth when you're falling. So that's when you're falling. But here, when you're on the surface, what's happening? I mean, some people think, I stopped accelerating. I'm not accelerating anymore. I was accelerating at 10 meters per second per second. The velocity, by the way, that as Sophocles pointed out, you don't get right away. It takes a while to absorb your actual gravity, so you don't actually move that speed. And as you keep staying in the gravity more and more seconds, you end up acquiring a lot more than 10 meters per second velocity. But anyway, your total velocity. But that has an absolute based on the friction with the air and all that kind of stuff, so you don't go, your terminal velocity gets stuck being your conflict in terms of friction. But if there was no friction, you could theoretically, if you go far enough out into space and somebody pushes you towards the Earth, theoretically you could reach the speed of light by the time you hit the Earth, theoretically. Anyway, so the point is, you're sitting there on Earth and everything seems quiet, like I'm not moving, but the truth is the force is still going through you, and what it's really doing. And then let's understand, and the Earth's doing this thing, the Earth is turning. So as the Earth is turning, okay, we're basically getting pushed down into the Earth, and the pressure is felt by the Earth. Your pressure is real foot-pounds go down into the Earth, but the Earth doesn't get compressed. It doesn't go down like a marshmallow. So it's fighting back. It's equal and opposite reactioning you right the hell back. So in a sense, the bits inside of you are constantly being pushed down and then pushed back up and then pushed down and pushed back up. So at different moments, different atoms inside of you might be going the upstroke, and another atom might be on the downstroke, and these are little tiny amounts of distance. That's all it takes, but it's happening all the time. And so as the Earth turns, you're basically bouncing. And a satellite in space is doing the same thing, in the sense that it's in a line of gravity and it has a velocity, but it's not really, turning a perfect circle. It's a least. It's doing this also. You see, but it's a much smaller amount of change. You're bouncing in heavy gravity. The satellite's bouncing in weak gravity. So even if the satellite's moving faster than the Earth, even if the satellite's going faster than the Earth is spinning, which they generally aren't, but let's say it was, it's certainly going faster because it's further out, so it's got to cover more distance. So let's say it's going 20,000 miles an hour, which is much more than it actually is. And you're only going, let's say, 5,000. Or, no, let's say you're going 100 miles an hour. Point is, you're doing it in this huge Elise. You're bouncing up and down much higher because you're in a stronger gravity and then the bounce of the satellite. I probably should have drawn it this way to illustrate it. This is their line and our line, because it's high gravity, is really high frequency. So the point is that you have to measure the total distance traveled to get the velocity, the actual velocity of the human being. So we're not just traveling the rotation speed of the Earth, we're actually traveling this whole bounce distance, and that's what equals the fact that we are the one with the more broken clock. So the broken clock is here on Earth. The clock that's moving slower is actually the one on Earth. The one in space is moving faster. We're the time dilated ones. And it's not because we're in, it's not only because we're in gravity. So by an Einstein theory, they just say, well, it's how much gravity you're in. Well, it's how much gravity you're in and how much velocity you have. The velocity adds to the gravity, makes it, it complements it, and so it adds more distance, which increases. So you're doing more distance in the same amount of time. That's velocity. And so they really don't get this entirely. But the truth is, Einstein's theory is basically just saying there's a relationship between what's demonstrated by the evidence is not a relationship between gravity, okay, and time dilation. What the evidence reveals is it has to do with velocity and time dilation. That's what the muons are doing. See, the muons decay slower because they're moving fast. It's not because they're moving through gravity. It's just because of their velocity alone, and that's all. And they're not leasing because they're moving with the gravity. Obviously, they're not bouncing, so their velocity is purely just velocity. Gravity has nothing to do with it. And that can sort of, I think, be inferred or understood. So you don't need bent space to explain time dilation. You don't need to bend space to explain anything that happens in this material universe. You can understand it as just rays of force. Straight line force creates these phenomenons, and that's an important one with gravity, and that's what I sort of attempted to illustrate with the drawing. It's like I said, it's not perfect. The two red lines doing the little archy thing are just to explain that what really causes gravity is any incursion towards something. So any component of your movement that is in this direction. So everything in this 179 degree arc is something, has a component in this direction towards something, and that's all you need to incite gravity in another body. So you incite gravity by just crossing that line. That explains why gravity spreads. That's why there's an inverse square law, is because two things will cause gravity between each other, but the gravity emitted by the pen doesn't go right to this blue thing. It goes, let's point them this way, it goes in all of these directions. In all 179 degrees is where the change in the force is spread over. So that's why the force gets so weak with distance, is because it's spread over that whole arc in both directions, by the way. Spherical arc. I have explained all that, but so I mean, it's just more evidence that this ray model completely fits with the circumstance. It describes it all, and it's just discounted because you have a preferential dogma. Because Einstein's declared a hero by the New York Times, and he's a world celebrity. You all grow up with this notion that this is reality, and you're just too rigid to say, oh, it could be we made a huge mistake, and maybe instead of saying Einstein is right on the New York Times headline, proven right, they should have said Einstein's interesting, but there's a better theory. It should have said something else, because you got the wrong answer. You chose the wrong explanation because you chose it too early, too soon, on too little evidence. You looked in the fog and you said, I see something big and hairy, and it was just 5 squirrels playing, I don't know, I don't know what squirrels play all kinds of weird games, but it wasn't what you thought it was. It was something else, and you're just too petty or insecure, or you're just too human to accept the fact that, oh yeah, I got snookered. I didn't do any thinking, critical thinking, and I let them do my thinking for me, and that was probably a mistake, because you see all the times there's people that don't have they're not infallible, and they're not perfect, and physics has every smell of being just a little bit too sloppy, and it's demonstrated. Like I said, in the current decades, it's been so reckless. I mean, the whole idea of just having conversations about dark matter when there's absolutely no evidence for it, except their theory doesn't work without it. I mean, that's the reason why it exists. That's the reason why we're speculating that there's matter out there that we can't see, is because they need it to fix their bad theory. Their theory breaks and has obviously holes in it. And the way they can fix the holes is they have to invent invisible forces, invisible mechanisms that we can't see. And that should be a huge giveaway that, alright, yeah, maybe we made a mistake. But instead, all I get is insults and crap from people for pointing out that, yes, don't pretend that you have some super evidence defending these theories, because you don't have super evidence. You have incredibly weak evidence. And I've said it over and over and over again, and the fact that none of you will acknowledge that simple, yes, just admit it. Yes, the evidence there isn't big, huge steel pyramids of power evidence. There's really flimsy, what did the three pigs, what did the one make his house out of, sticks or something? Mud. Yeah, it's mud. It's not even close to the brick house that you should have if you're going to be this obnoxious, this arrogant, and this completely unwilling to concede you might have it wrong. You might have made a mistake 100 years ago. So I guess that's enough of that. We'll do one comment that's related, and we'll call it a day again. Well, we'll call it an afternoon. Maybe I'll be back later. I'll be back. And such. Alright, so Yam 21 Yum. Alright, a guy with no content and a completely silly name. And he's going to just talk shit. And you're just saying, I mean, what do you want me to say? You think you're going to make an argument to me that's going to be in any way persuasive, and that's what you fucking, you present yourself with. Those are your credentials coming in, are, Bozo the Clown, big feet, and a red nose, and, pink hair. Fuck. Anyway. Different person, same narcissism. So again, as if narcissism would matter. Who cares? I don't care if Ken Wheeler is a narcissist. I don't care if he's incredibly egomaniacal. If he actually presented some evidence, who cares? It's okay to be obnoxious if you actually bring an argument to the table. Now, if Miles Mathis wants to be a narcissist and be full of himself, well, again, the argument is he's completely incapable of defending any of his theories in any kind of real way. He won't he won't go on a message board, he won't argue his imbecility. He doesn't show up on, he does this pi equals 4 thing. He has a guy put YouTube videos up. He doesn't defend any of his crap. So anyway, so that's bullshit. Alright, you think there's some kind of conspiracy. Now again, so another accusation has nothing to do with what's being argued. I think there's some kind of mistakes being made, and I think your heroes, your eggheads, are nerdy, phantasmagorical, silly people. Okay, they might be smart in the sense they might have some, a substantial amount of knowledge in a certain subject, mathematics or something, but that doesn't make them immune to being silly. And yes, I think they're silly. I don't think they're terribly logical. I don't think they know much about the real world. And I don't even think they know much about how you do the intelligence thing. They're too busy saying they're intelligent, not busy enough understanding what the nature of intelligence is. And one of the things that makes you intelligent is the capability of smelling bullshit, smelling nonsense, smelling something that was made up, a fairy tale. That's one of the things that makes for intelligence, and they don't have any of that. Alright, you think there's some kind of conspiracy where all the magnets in every anti-particle accelerator, I don't even know what that is. An anti-particle accelerator? When did somebody invent one of those? When did that happen exactly? Are flipped? Are the magnets all know somehow to flip themselves? Again, nothing like that was my argument. My argument was it's a medium, and that the little bits are traveling through, and that depending on what kind of radiation is being pushed into the medium will end up having bits that are more or less ionized, and that the more or less ionized they are, the more likely they are to capture electrons in certain condition, close to a proton, far away from a proton, all that kind of stuff. So all I made was a logical argument that maybe there are circumstances where the electron behaves, okay, the opposite, because it's more controlled by the local environment, that is the environment in the medium, because the medium is now kind of magnetized by the ions, and that it's doing the local charge field is affecting it more than the magnets, the wider magnet field. So the more distant field, although stronger, isn't stronger than the local field. The local field always counts more. And that's why you see more electrons turning a way you don't normally see them turn. Alright, anyway. But that's all I proposed. I didn't propose anything insane beyond a reasonable explanation. I just speculated that there could be other explanations for these particles, and then I speculated that they could just be that, yes, protons are very big compared to electrons, and maybe protons are actually more than one proton, you know, that there's a more fundamental element to a proton, and that those can be released and they would behave like opposite of an electron. But they're not the opposite of an electron, they're just a proton. They're just a piece of proton. A piece of proton is not a possibility is all you're saying. You're saying it's impossible, it's a ridiculous notion, nobody should not even think about it for a second. It's not worthy of 1 second's thought to see if that simple explanation might be true. Because you're so certain that your evidence in your fog chambers is so empirical, is so perfect, that no one could ever dispute your conclusions. Anyway, so he just lies. Again, like I said, I didn't say anything about magnets being flipped or the world having to be turned upside down or you have to flip the universe over. I didn't make any such accusations or concepts or dependencies in my argument. So it's just this willingness to lie. You know, what is that a sign of? It's a sign of your desperation. The fact that you can't treat my arguments fairly, isn't that evidence that you're the desperate one? You're the one lying about me. I'm not lying about your arguments, asshole. Okay. Flipped, our magnets all know somehow to flip themselves to deceive all the incompetent eggheads. So he called them eggheads. He considers that, I suppose, what they are. Okay, I never used that word. And competence is a tricky word here, because yes, I'd say one of the things that scientists are supposed to be is they're supposed to wait for the evidence. They're not supposed to put the cart before the horses. Alright, they're not supposed to put the conclusion before the evidence. And I would argue that this is one of their incompetences. That they have carts the dark matter is way ahead of any of the horses. Way, 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 way ahead. And I would argue that even conclusions about antiparticles existing for every particle, those conclusions are way ahead of any horses you have. Okay. That's exactly what I expect to hear from Miles Paranoid Mathis. So the fact that Miles Mathis is paranoid is, again, irrelevant. And what would that have to do with any of this? Again, where's my paranoia showing? I'm not the one afraid to fairly argue here. I'm not the one exaggerating somebody else's statements. You are. I'm not the one using this derogatory commentary. I'm saying the evidence is weak. That's my primary accusation. The evidence of the Standard Model is incredibly weak, way weaker than something called a scientist should accept hard conclusion, or dogma. They shouldn't be writing it in the book of truth. And they do it all the time, especially those LIGO people. Go watch them some. Go watch a video by one of those LIGO people, and they'll keep telling you what they know for sure. They know there's dark matter. They know there's dark energy. They know, and they'll just keep, we know, we know, we know, we know. That's what they keep saying. We know. And you're saying that's good science. I'm saying it's exactly the opposite. Let's see. Not only that, but fuck chemists, right? So again, where did I say anything against chemistry? Where? I'm talking physics. So yes, chemists don't decide, okay, how you're going to build atomic structure. They just take the atoms and make them fit together. So there's nothing wrong with the standard little chemical models don't have a bunch of moving electrons in them. And that's the beauty of it, is that works. Not moving electrons makes it really possible to put the stuff together. So I would kind of argue that chemists probably have it right, in the sense that they're using models where the electron isn't going flying all over the fucking place. And I would argue that makes a lot more sense. Who the hell knows what a proton emits during atomic n changes, atomic number changes? Who the hell knows what a proton emits during atomic number changes? So again, I don't know how I made any accusations about saying I know exactly what happens. You're the one saying you know exactly what happens. So again, I don't understand. I'm the one saying it might be possible that yes, protons can be degraded. You're the one saying no, that's not possible. Let's see. It only makes sense if protons emitted electrons. Well, why would a proton emit exactly the opposite charged element? So I don't know how you do that. Why would something that's all red produce a black thing? Why would that happen? Why would I think that happens? Sorry, it doesn't make much sense to me. It's not just bubble chambers, you ignoramus. So I'm the ignoramus when, what else is it? Cloud chamber, bubble chambers, what other chambers do they have? I mean, you're implying that there's some other magic chamber. So why don't you give me an explanation of the magic chambers they use to see protons and electrons? Show me where they have a picture of one that wasn't in a bubble chamber or a cloud chamber of some kind. What other kind of chamber do they have, jackass? How else do they see anything? How else do they record the event? Butthead. So again, you just make this garbage accusation that somehow your evidence is stronger than I am willing to admit somehow, and yet you're not going to put up any of this evidence. You're not going to show me how it's not just, when that's exactly what it is, just. So keep pretending it isn't, but it is just indirect evidence. We have no mastery of some smaller bit of the universe to do this with. Just don't have it. So where's your evidence for your arrogance? What's your excuse for lying about what I said? Why do you have to lie? If you have such a superior argument, and if you're not some kind of narcissist or some kind of sick person, some kind of desperately deluded person, why do you have to lie about what other people say? Why do you have to lie about your facts? It's not just bubble chambers, you ignoramus. Well, what else is there? Explain to me what medium they watch electrons and protons travel through. Explain to me the instrumentality that you think is above reproach, that is such a perfect instrument for viewing electrons that how could I possibly deny the images? How could I deny the information? So show me the information source you have that is so perfect that nobody could sit there and say, well, there's a lot of things that could cause that effect. Show me where you have these clear cause and effect links that you can be so obnoxiously arrogant. And why don't you put your name on this crap? You know, just for posterity, just so just so everybody knows that you sat here and harassed a person, you lied about them, you provided no counter evidence whatsoever, zero, and all you did was make a bunch of ad hominem attacks. In defense of what? Your golden eggheads. Your infallible golden eggheads that routinely can't describe the simplest experiments in physics, the double slit and single slit, accurately, propose all kinds of Copenhagen many worlds, they invent universes, they invent dimensions at will, and that's supposed to be good science. You just invent them. If it works, go ahead. If the Three Bears works, sell it. You know. But I guess they know they can't get away with the actual Three Bear story. They can only go so close to Leprechaun. I mean, even though bent space is really, I mean, a dark matter is just a leprechaun. I mean, it's a leprechaun in every respect, just about. It's not in a green suit. It doesn't have the funny hat. It doesn't have a shillelagh. So, but in every other respect, it's a leprechaun. And you're going to sit there and ridicule other people. Amazing. Yeah, sorry, you're an asshole, and you deserve to get punished for being such an asshole, such an aggressive, nasty, stinky, smelly asshole. Hopefully I'll be able to do that someday. I'll have the power yeah, to find you, make you pay. Alright. With proper humiliation. Anyway, till next time and such, and so forth and whatnot. I mean, you're just all clock stoppers. You're just like the religious fanatics in Darwin's day. No, 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 we can't have none of this monkey talk. That's all you're doing. You're reactionary, you're the paranoid one. Somehow your magic is going to fall apart or something. What are you afraid of? You know, what is it? What's the underlying... See, Ken Wheeler's sort of outing himself as some sort of religious kook. You know, he's doing some kind of thing in July, and in his write-up it has all this Buddhist stuff in it. So he's apparently, that's okay with him to be described as a Buddhist and all this other bullshit. I thought he was ancient Greek. I don't know if the ancient Greeks had anything to do with Buddhism, but whatever. But anyway, you know, it's agenda physics. You clearly are agenda physics people. What is it for you? What is the magic hope that you have? You really believe there's aliens and there's a singularity, or what is it? There's something that keeps you glued to this stuff so strongly that you just can't imagine the universe without your magical time travel or something. Is that it? You're going to do your silly love thing like in Interstellar. Love makes the world, the universe run. The universe is made out of love. Is that it? Anyway, whatever it is. Fuck you. Yeah.